This will be our third video on sampling distributions. In this one we'll talk about spread. You should hopefully have already watched the video on shape. So having watched that video, you know that it's going to be mound-shaped symmetric for the moment. We now need, here's our center, and we know that we have 3 standard deviations that go out, and what we need to know is what that measure actually is. That's our measure of spread. So let's look at two different examples now. We're talking about reading ability. We have a new set of activities that hopefully improves reading skills, and none, just the regular curriculum without the new activities. Is there a significant difference? We also have, does aspirin alone versus aspirin plus a different chemical, which is an anti-clotting chemical. So does it reduce the risk of a second stroke? Well, what we need, let's quickly just identify the shape. We know that we're dealing with the mean of this treatment group, the mean of the control group. So we're dealing with the means. It's 2 sample. We want to know if there's a difference between these 2 samples. Unknown population standard deviation, t-distribution. That's a review from the last video. In this one, of course, we're given counts. So you might expect this is going to be proportions. This one is also going to be 2 sample because we're looking at, is there a significant difference between these two? Still don't know the population standard deviation, but as we talked about before, for proportions, that doesn't actually make too much difference. All right, we're going to be talking potentially about a normal distribution. So what we're going to now talk about is how do we actually calculate the measure of variation for these distributions. So the first thing I want to do is, here are 2 examples. Let's get the summary statistics for these. So we have our treatment group and our control group for the reading program. Test score averages, sample standard deviation, sample sizes. And over here we have our 2 proportions for our 2 samples. And are these significantly different? Notice that I actually made a point to say, no, we actually haven't verified that it's okay to use these distributions, and we need to. I don't want to, waste some time on this particular video. I verified in the last video, but I want to make sure that you realize you do have to verify those. And to calculate the measures of variation, we have this wonderful table right here. In this first example, we'll go back. Right, we have a t-distribution, 2 sample. So in looking at that, we have, and we're dealing with means, t-distribution, 2 sample. So right, here's our standard error. That's our measure of variation. Because it's a t-distribution, we are going to have to talk about degree of freedom. We'll do that in just a moment. But I'm going to copy this equation down right here. And at this point in time, it's a matter of plugging in, S1 and N1, S2, N2, cranking the numbers, and we have our measure of variation. Now, we do have to think about degree of freedom whenever we talk about a t-distribution. Let's look at this big box. We have kind of 3 options. This one down here is not usually done anymore, just to let you know. When you're doing it by hand, this is the one that you typically use, which is just the least of these 2. The calculator or computer, when you use those programs, this is what the computer uses. And we could do this and plug this through a calculator by hand also, but kind of a pain in the neck, and this one is considered conservative and good enough. So this is the one that you're typically going to use most often, unless you're using a computer program, and then the computer uses this one. So here we have the least of these two, and so of course our degree of freedom is 20. Now over here, we're talking about proportions now, which of course are only normal distributions. We're still talking about two sample. Notice that there's kind of these two parentheses up here for confidence intervals and for tests of significance. We are doing tests of significance. So we are coming down over here, and this is going to be our standard error. And it uses a pooled proportion. Right? Whenever you're, and this what this little note says, is our null hypothesis is that the two proportions are in fact the same. So what we can do is, say they come from the same population really, and so we can just put them together. So here is the pooled proportion, which does kind of make, especially because the sample size is so close, these would be pretty close to the average of these two. Now, if the sample sizes aren't equal, then this won't necessarily be in the middle. So here's our pooled proportion. And then we're going to use that standard error equation giving us that standard error in the end. So really, we have our two proportions, right? This is our t distribution. Oops, distribution. All right, this is our normal distribution. We identified the shape, didn't verify it, granted, but we'll continue anyways. So what we can do is draw these, which would look something like this. And of course, this is t distribution, right, of means. This is a normal distribution of proportions. And we know we have three standard errors that go out. Three standard errors, well, and I'll fill that one up a time. And I'm going to have to do this from the center, and we haven't talked about center. That's actually the next video. But if these are all the possible sample means, the center of all possible means is actually going to be your population proportion. And so these locations, in terms of mu, would look something like this, in which we're going up by increments of standard errors. And we know we have our 68, 99, 99.7 rules that we can apply to this distribution. And it goes in the other direction as well. And we can do that over on this other one. And it'll look something like this. And of course, subtracting to get the other side as well. Once we have that, then we can, again, start doing all kinds of good calculations once we know what the center is. And that's going to be the topic of the next video.